Hello, everybody. I'm really happy to be part of this panel and also looking forward seeing the other presentations. I'm Guillaume DE MORSIER, partner of the office KUNIK DE MORSIER based in Lausanne, associated with Valentin KUNIK. We founded the office in 2010, just after our graduation here in Lausanne, also at the EPFL. And since few years, we work together with Virtual Switzerland, and we developed this new initiative, which is called Agile Space, where we question the way we can introduce extended realities into the construction industry, so to say. We have several partners. Some are academic partners working with digital technologies, architecture, timber and wood fabrication, but also climatic and sustainability experts, computational designers, and also investors and developers. So we try to have all the actors of the construction to discuss the possibilities, what we can do with these new technologies. So I will go through a few projects from our office, and then you will see how we try to implement step by step these technologies and what might be done in the future. In our office currently we have four main interests. The first one is the interest in the co-design. So since we started the office, we always work really closely with the stakeholders, the users of the buildings, and through a series of immersive workshops, design thinking workshops, agile methods, we bring all the actors of a project together, and we really work closely with them to co-create the project. And it's something that is really, really important for us, because we don't see us as master builders, but more like bringing some skills to a larger, wider community that is working all together. Our second interest is the environment. We integrate from the early beginning the environmental factors, geographical factors, climatic data, microclimate in the early stage of design. This is something really, really important for us, and it's something we must do to tackle the current issues regarding the climate and the net zero construction we aim to reach. The third important topic is the topic of resources. We also integrate all the questions regarding water, energy, biomaterials, geomaterials, material reuse, really at the core of our projects. And then last is these digital design tools that we try to integrate, and it's like, for example, the simulation tools, optimization tools, virtual prototyping, and fabrication. This was one of our first projects. It's a small hut in the mountains. It's all made in timber. It was really funny because the client wanted to get rid of the idea of the normal house with two floors separated. They wanted something really continuous and more three-dimensional in a way. And so we developed a structural system out of wood, which works more like a kind of construction game, and then is able to be really, really flexible and to provide more like a three-dimensional continuous space that you can see on these drawings. It was really interesting. It was the first time we were really working closely with a timber contractor, And we started to look at ways to make the communication between us more fluent through 3D models. Here you see the house, and you see the upper level, so to say, and the external items. From that, we developed a series of competition. This is one example where we try to go further in this idea to use wood in a kind of structural way, and also use all the cutting technologies that we have here in Switzerland. Meaning that we noticed that every timber builder has a CNC router, and that it's really easy actually to build complex structure. They use it to build very simple things, to cut simple pieces, but we could really go further in that and bring complexity into reality. So it was an interesting competition. Unfortunately, we lost it, but the idea was to see how we can fabricate slabs that are not horizontal, but that where the geometry is optimized to catch as much daylight as we can in the winter time. And this geometry was really, really simple, or is really simple to build out of wood, because even if every piece of wood has its own geometry, it's machined, so there is no need of calculation. Everything comes out of the computer somehow. And then from that, we started to raise a few questions, and we were interested to use open source building systems. We were interested to take advantage of pervasive CNC wood cutting system, as I explained before. We wanted to integrate also these logics of DFMA, design for manufacturing and assembly, that is mainly used in aerospace industry, where we, at the early stage of the project, we can anticipate what will happen when we assemble the aircraft, the car, or the building. We also wanted to promote this idea of the possibility of mass customization. So today we produce buildings that are kind of all the same, but then with digital technology now it starts to be really simple to make buildings or flats or structures that are differentiated. And this is something we try to integrate also in the reflection. And then really specifically regarding the extended realities, we wanted also to integrate this in our workflow. First, to help us to make kind of rapid prototyping instead of building models, physical models. We can really more rapidly see in the space, in the room, what's happening. Also, something we are really interested in is to see whether it's possible to visualize invisible things, for example, environmental factors on the site, and also see how we can bring these technologies in a workshop or on a building site. This was another project. It was built following the concept of Wiki House. It was a floor, office floor, where we had to build meeting rooms simply. And the idea was to work with this principle of open source timber construction. It's an open source system that is developed for about 10 years by quite important community worldwide. And from project to project, the code, the design system is optimized, and everything is open source. And with that project, we also contributed somehow to the development of the system. So it's something really interesting because it works with only one type of timber panel, and everything is cut on a CNC router, like this. So all the pieces are extracted automatically and then printed at the carpenter. And then it's assembled on site. And what is really interesting is that the system is really lightweight, so you can handle every pieces of that puzzle, and it's really quick to assemble. Then you see that you can reach any shape that you need for the space. In that project, we built 3 different types, every type with different acoustic conditions, light conditions, etc. And this is the second project I want to show. It's another it's an industrial project. It's a big hall, and we had also to make a lab space and office space where there are boxes for meeting rooms, but also for labs, white rooms, dark rooms, etc. And for that, we use the augmented reality. I will show you. It goes. Oh, sorry. Yeah. So the first step was to see, as it was in an existing building, to see how we can use these. Simulation, daylight simulation, to optimize the position of the boxes in the space. So from that optimization process, we ended up with one optimal solution. And then here, this is the 3D model. We work directly with the timber construction constraints. So you see the different layers. Here, these are the roofs made out of foil. Here are the hard roofs, the lighting system, and this is the 3D of the space. From that, so this was made on Rhino. We tried the 3D, and from that we use this hologram plugin that allows you to send Rhino 3D model either to a tablet or a smartphone, or to HoloLens 1 and 2. Sorry. So this is the space. So we made a grid on the space, and on each point we made QR codes like this. And this QR code allows you to geo-localize the project in the space. From that, I will start a small video where we see, here you see I snap the QR code, and then the 3D model is overlaid on my tablet. And so you can go through the space with the contractor, with the stakeholders, with the client, with the users, and test several versions. Then you confront one-to-one the project with the reality. And so it was really interesting for the clients, but also for the contractor, because we could see conflicts with the technical installation and so on. And this is then 2 or 3 weeks later when we brought the timber elements. Sorry, yes, it's a few pictures. And this was 2 weeks ago. It's really recent, and this was 1 week ago, so it's really almost finished. This is a third project. It's smaller than the 2 other one, but it's interesting because it goes a bit further in this idea of using AR or mixed reality in the field of architecture and design. So it was a training organized by Hologram, the Hologram programmer. We attended in London. So this was the object we built, and all the plans instruction were made using augmented reality. So the principle is it's a kind of complex structure where all the pieces have different geometries, and everything is built simply with aluminum rods. Here you see the rods. And here you'd see this, at the bottom of the screen, you see a red small machine. This allows to bend the rods. And here you see closely how the rods are connected all together. And here it's another video, so you will understand how every rods, which has a different geometry, is folded following the instruction coming directly from Rhino. So you see in red, this is the shape you must reach. And so just follow the instruction. And there is a small gap because I'm shooting with the camera, but the operator is using the HoloLens, and the precision is like millimetric. So it's really it's really enough the precision you have to do these kind of things. Tack. And this is another one. Okay. Here you will see the whole process. So this is the rod you see in red the objective, and here here in AR also you have the buttons to go from rods to rods, and when you select one rod to go to bend 1, bend 2, and bend 3. And then, so when you make your bend, then you just it's mixed reality with the HoloLens, so you can snap that shape and it goes to the next one. So it's really made to work in a workshop and environment, I would say. Put it quicker. So here, yeah, they are cutting the rods, right dimension, and then the fold, you saw it before. Yeah, and this is the finished structure with even we had some fun putting a kind of a facade on top of it in the end, dynamic sheets. So this is it's really interesting because it's a very small object, but it shows the possibility that we have to go directly from a 3D model to construction instruction, and to somehow we can get rid of the idea of the plan, printing plans, of reporting dimensions. Everything can be overlaid and cut, bended, whatever you need to do in a workshop or on a building site. Sorry. So from that, the next step we are now interested to develop is decided to bring more complexity into the design by, as I showed before, by overlapping complex geometries in a workshop environment. Also here you see this is also possible with brickworks, for example, where all the brick layers can follow the geometry that you overlay. And this is another thing. This is a competition we did recently also that we want to develop through Agile Space, is to see how we can on site, in a site, start to visualize environmental factors like the wind, like rainfall patterns, like sound, all the invisible things you don't see when you visit a site once, but bring this kind of this big data that exists in the site through these technologies. That's something we are really interested to develop further. This is another image where you see we overlay these informations to see how the design can really directly relate to that. So that was it. Thank you very much. Don't hesitate to contact us. Here is my email. Also, you can contact Laetitia to have further information about that fantastic adventure we recently started together, and we'll continue for sure within the next 5 to 10 years. Thank you very much.